Hey everyone. So a couple of days ago, I posted a blog post, or whatever you call it, on our website titled Scriptable Objects Will Ease Your Sorrows. And the point that I was making in this blog is that scriptable objects can be used for a variety of different things, not just like kind of super custom, easy to create file types, I suppose. And they're very useful when you want data to be shared with different mono behaviors in Unity engine, of course, is what we're talking about here, and specifically. But what's interesting is that scriptable objects basically have everything that mono behaviors have. Not everything, but a lot of the good features, the important features. But what's interesting about them is that they can exist outside of a scene. And so this kind of would give you an idea that maybe you can use them to do types of things that maybe you tried to do in the past that you don't realize you shouldn't have been doing, or you shouldn't even try to do. And scriptable objects were kind of like that pathway to doing it. And so this is kind of the mindset that I had when making this blog post and when designing some code while making this blog post. And so these were these two videos. I'm not going to put them in the description. You can check out the blog post. It's right there. You can click on them there. But essentially, I was thinking to myself, oh, so I can use scriptable objects to make a sound system where basically this sound system would be a class. And when you start the game, what it would do is it would create a bunch of prefab instances that would exist in the don't destroy on load special scene that exists in Unity. You pull them all in there, keep track of them using that class, and what would happen is that what was I going to say? You can let me scroll down here while I'm talking and get to the picture. Basically, you can use static functions to say, I want to play a sound at this point. And so the idea is that effectively what you would do, let me just throw it out in Notepad what I'm talking about. You could do something like, say, for example, audio system dot play sound, and then you can have your sound clip or something like that, and it would play the sound. And all it would do is it would just grab one of the audio objects from the pool and it would play the sound. And so what this means is that if you had, say, for example, sounds that were being played and they were being played in rapid succession, and each sound had a slightly different pitch applied to it, so it could be a little high pitch or a little low pitch or whatever, and you had these playing repeatedly. And so what this means is that each time it's going to grab a new sound object, and therefore there's not going to be any audio cutting, because one of the things that you might realize working with sound sources in Unity is that if you use a sound source and you do not sound source, audio source. If you use audio source and you do .play, if you do something like then afterwards, if you say audio source .clip is equal to some other clip other than the one that's being played, I think what it actually does is it stops. I don't know if it actually stops the song, but essentially you can't have two clips playing on one sound source at the same time. That's just to keep my explanation simple. So I don't know if that interruption would happen when you change the clip, or when it would be the next time that you played, you called the play function. And so a lot of people go, well, I don't like that. But the best answer I give to people who are in the same predicament that I am, or that I was maybe, is that essentially you just want to use multiple audio sources. That's the goal here. But what I was also going to say just now is get over it, because that's just how it works. That's just how audio kind of works. I wish I kind of knew the deeper insides of how exactly audio was handled in Unity, because there is indeed a thing called audio. Well, not it variable name dot, and the function I believe is called play one shot, which is quite interesting because then you could, as a matter of fact, play with one audio source, play multiple sounds. The only problem, of course, is that you can't apply a specific pitch to each audio source. All you can do is change the volume. You can't change the pitch. Each one can have a unique pitch, and therefore, if you have a unique pitch, like if you're kind of randomly changing the pitch for each new sound, then you're gonna run into issues. And so all of these kind of issues and kind of goals of how I want to be able to use sound in our game and how I want to kind of implement it, I was kind of stumped, and I was like, oh, let me make this system that just pulls a bunch of audio objects, and then I can use them whenever I want, on demand, anywhere in my code. And I think ultimately the takeaway from this venture is that you shouldn't be trying to make something like this. You can, and the way I was doing it, it didn't really work. Like, it didn't end up working, but you can make it work in a different way. That's my point. But either way, what I realized speaking to some other Unity developers is that this isn't really a nice way to go about designing a system to play sounds and do these types of things. Although, if you're making a smaller project, this could be totally fine. This might be a nice little thing where you can, take this code, drop it in whatever, and have it do its thing. Anyway, let me get to my point here. So, in this code that you see here, can I zoom in on it? I can, actually. Basically, I'm using this one, and it probably has some use, but the thing is, it's something you're not really supposed to use that often. And essentially, it is this attribute called Runtime Initialize on load method. And it allows you to basically run some code when the game starts, no matter what scene is loaded first. So this could actually be very useful if you want to design your game where no matter what, you will, like in edit mode in particular, no matter what, a certain scene will always load first. And then once that scene is loaded, there might be some stuff in that scene that performs some other logic. And then once that's done, the scene might unload or and then you'll load in some other scene or something like that. So if you want some sort of initial thing to happen in your game, then this might be a nice way to go about it, but it shouldn't be it shouldn't be the first thing that you go to. Like, you should try to find another way to do it. Although I can kind of not resonate, I can relate to people who are like, I just want to have a class and have a bunch of static functions so that I can like do something like, if you have a database in your game, I'm rambling, but if you have like some database in your game like we have, and you just want to say database dot get this thing in the database, you just want to have a static function. But you don't necessarily need to have something like that. You really don't. What you do need is some sort of data that can be globally reachable. And Unity provides other ways to allow you to do that don't include static functions, which are nice because it means that you have a level of modularity that you didn't have before. Static classes can take away, depending on how you use them, and this is the key point here, is that they can take away a lot of modularity, even though you think, well, static functions, if you don't need multiple instances of something, you only need one database, then why not make it static? And here's the answer to that. Functional programming is meant for only certain things. I'm still rambling. I know I don't really need to say this, but I like to. But functional programming, I've learned recently that functional programming is kind of like, it's a different realm of, you'll have some people who will like, be like, object-oriented programming is bad, and this is why functional programming is good, stick with C, stick with C++, or something like that. And they'll kind of like complain about all the problems of object-oriented languages, and I can understand those arguments, But at the same time, that doesn't mean you can't get something done and you can't make something good with object orientation. But with that being said, the static keyword really comes from that demand for being able to code in a functional way. So say, for example, in Unity, here's a good example. Not in Unity, in C#. Well, technically Unity. In Unity, you have a struct called vector3. And it has some stuff in it, but most importantly, it has 3 floats, an x, a y, and a z. And what if, say, and of course, it has a bunch of functions inside of it as well. It has a bunch of functions that do different things. And you go, well, why isn't there a function in that class for doing, something else, some mathematical operation with vectors that they didn't think of? Well, fear no more. You can just create a class, a utility class or something, and now some of you probably knew where I was going with this. But you can say public static void, do a cool thing with vector. And then you can take in a vector3, call it whatever you want. Doesn't matter. And do something. And then, of course, probably what you also do is not make it void, but instead, do that so that you actually have a result. And so the point is that the static exists so that you can have functions that don't necessarily relate to some data structure within the class, but those are just a bunch of functions by themselves that you can use. Of course, there are extension functions, which are also very useful because they kind of make the syntax a little bit, the language, the way you read the code. You go, okay, this is an extension function for this particular class. And so it kind of streamlines that idea of, here's a function that takes in this thing, and it could be in here, but you can't put it there because, that class is locked away because of just the nature of object-oriented languages. But what's interesting is because a lot of functional programmers would say to you, well, doesn't that suck? Wouldn't you like to be able to put this function in here and then not have the static and do all that? When you say, well, guess what? There's a system that allows you to do that. It's called this language or whatever. Something along those lines, would be a potential argument that certain functional programmers would be like, this is why objects are stupid. Just keep it functional. You can still have your complex data structures, but keep the functions separate or something like that. Anyway, that was my ramble. So my point is that really that's one of the ways that static is supposed to be used in C#, not really for, you can, but not necessarily for like a system like this. And in fact, all that I'm really trying to do here is give myself the ability to separate out, to be able to play multiple sounds at the same time and not have them cut each other off, because a sound source can only play one sound, but then also be able to change the pitch. And so this never worked out the way I wanted it to work out. And this one person on a Unity developer Discord basically said to me that I really shouldn't be designing it in this way. But the point of this blog post is just that I'm trying to, at least I was trying to kind of say, hey, here's a way you can use scriptable objects. Here's, so I'm not trying to say that this code here is like completely crap. But what I will say is that if you try to use this code in a different way, what I want to say is that on enable, this particular Unity event will not be called when you build the game out as an exe and run it. It only happens in the editor. There's an inconsistency there. And that's probably going to be a lot of issues that people are going to have with when they build their game, is that there's these inconsistencies. It's like it works in the editor but doesn't here. And if that's the case, usually you're using something the wrong way. And the reason why on enable it gets called is really it only gets called when a scriptable object is enabled. And so what does that mean? It kind of doesn't really describe what's going on. And in this case, onEnable along with onDisable will be called when you hit the play button. And what's interesting is that onDisable actually gets called first, and then onEnable gets called. And so that's kind of a hint to what's going on. It's that in the editor, the audio system is being turned off. It's being disabled, so you can kind of do some function in the disabling part in the editor, and then when you run the code, it'll re-enable itself. So, but then of course, in the if you were to build the game out as an exe or as a standalone program, it never gets called. And so why is that? And so the reason why is because the file itself, the reason why that onEnable gets called is because you, first of all, you have an actual instance of the scriptable object in your assets directory, in your project view. And so here I have one, of course. And in this case, you're only supposed to have one. And so when you run the game, what happens is that it gets stripped, air quote stripped. It never actually makes its way into the build because it's not referenced anywhere. So you have to reference it somewhere, and it's like, well, where are you going to reference it? The point is that you don't necessarily want to be referenced anywhere. You just want it to exist by itself, and for Unity to acknowledge its existence, essentially, so that you can kind of run this singleton-like thing, which I coined funnily enough, I coined it the scene transcendent singleton, because it's a singleton that does not exist within the scene, which could definitely be useful for people who are using singletons in their project, and you're like, okay, I want this logic to run, but it doesn't matter what scene it's in. And that's kind of why I went down the path I did with the sounds. But anyway, let's see, what's this? Oh, this was another thing I was saying. I had a bunch of final notes. Final note. Another final note. I'm going to have to edit this part because this is I said in here I was going to make a follow-up. And this is my follow-up. So essentially, let me get to my point here, because I've been doing this for how long now? Probably 10 minutes. I don't know where the timer is. Anyway, so this is, here we are. This is my solution to the issue. So instead of using a singleton to pool a bunch of objects, I decided to do this a little bit differently because I realized that, and this way is actually a little bit better than the sound system, because if there's a bunch of sounds, playing all at once in the game, and they're all, calling from the audio system. Well, first of all, they all depend on the audio system. So now, if an issue happens, and one object's playing a sound and it causes an issue with another object, well, guess what? It's going to be it's probably going to be very difficult to figure out what the problem is if the problem is being caused by two objects that might have nothing to do with each other because they're all sharing the same data. Which first of all, actually, if you're going to be making your game multi-threaded, is going to introduce its own problems. Static variables can in fact introduce their own problems in this case. And so this system is basically kind of like taking the audio system and going, let's take our idea and kind of compartmentalize it and fragment it and break it into pieces and allow objects to pull their own sound sources, which means that there could potentially be more than 100 sound sources, like you can see here in my code. Is this the right? Hold on. Oh, it is the right one. I just removed a lot of code, so you didn't see it. But originally I was like, I'll pull 100 audio objects. But in this situation, there could be more than 100, which is totally fine, because there could be more than 100 objects in the game. And so if there's more than 100 objects and they're all playing sounds, the audio system would very quickly get not encumbered. Wow, how did that word come into my mind? Get overwhelmed? Yeah, overwhelmed, that's the word. With, sound requests or whatever you want to call them. And so then very quickly, you're going to have all these sounds getting interrupted, and the underlying sound system is going to just be it's not going to be confused, but there's going to be probably issues. So this system is a lot different. It's essentially just a mono behavior. And if you want to copy this code, go ahead. Just don't copy it verbatim. Do it code it the way you would want to code it. So you can code it off of the way I explain it. And so essentially all it does is it basically creates its own mini pool. So this object, whatever you attach it to, it'll create its own mini pool of objects, audio source objects. So as you can see here in the awake function, you could do it in start even. I chose awake because awake always happens first, and it's like, although technically I feel like awake is only really meant for get components, not really other things. So it might be more appropriate to put it in start, but I'm like, if there's no issues, just put in awake, and so essentially, as you can see here, it's looping through, and I'm doing this, I have this list, which is my pool of personal audio sources, although I could call them pooled audio sources, doesn't matter. And I'm adding a bunch of audio sources, references to the list. In this case, there's a function I use to kind of make my code nice and neat called create audio source, and essentially that's at the bottom here, and it just creates a game object. So there's not even any prefabs involved, which is nice because now it's like, this code, it could very easily be put in another project, and it'll still work the same way. It's not like, oh, you also need this prefab for it to work. It'll just work by itself. I like mono behaviors in code that works like that, where it's like it doesn't need any prefabs or any other crap. It just works. I like that. And so I'm setting it to false, although I don't think I necessarily need to do that, but it actually makes it really good at visualizing how many sound sources are used, and I'll show that in a minute. And just setting up the data. And so this is something that happens only once in the game, or it happens once on awake, so on initialization. I'm also using this gizmos. I didn't use update because I didn't want that little checkbox by the component, so I just use gizmos there. And I'm basically saying, okay, if looping through all my objects, and if one of them is not playing, then set its active to false. So this is something that wouldn't actually happen when you build out the game, which means you're going to have you're just trying to optimize performance, but also optimize debuggability, if you will. And then of course my almighty function play sound effect, which takes, actually this is a really good example of how to use scriptable objects. So sound effect group is another class that I made, and all it is a scriptable object, and it contains a list of audio clips, and along with it, it contains a volume number and a pitch range. And so the pitch range is just a vector2, and you can see here, basically there's this function called generate sound effect, and I decided to make another class to make like a simple struct like this.